Hi, for those of you that would like for me to finish or just kind of go back over some of the things we talked about on Wednesday, I decided to put an optional video in. Here we go. I believe with both classes, I explained that our end goal with our u is to get it to a constant. And so that's why if you have just a power function in front of your transcendental function, that's 9 times out of 10 going to be your u. So we've got this integral of x squared cosine of x. And I also believe I said that as it increases in power, that's the number of times you're actually going to have to perform integration by parts. So I'm going to do the parts for you twice. Then I'm going to show you a shortcut, and then we'll apply it down there on this nasty little x to the 6th cosine of x. And I also, for a reason that I can show you later, and I know I did this for C block, I changed it to x squared sine of x. But the process is the same. So we'll start off and we will let u be x squared and dv be sine of x dx. Differentiating u, we get du to be 2x dx. And taking the antiderivative of sine of x, we get negative cosine of x. And then let's just over here to the side, remember that when we have u times dv, which is what we've split this up into, u, and there's our dv, that's equal to u times v minus the integral of v du. So I'm going to put that together here. So my uv is negative x squared cosine of x minus a negative, so plus the integral of 2x cosine of x dx. So that's putting my du and my v together. So you can see that I've at least knocked the power down by 1, and I'm going to have to do parts again. Let me change colors just to, keep things interesting. And we're going to rewrite our v du here. So my new u is 2x, and my dv is cosine of x dx. So differentiating u, we get 2 dx. And taking the antiderivative of v, we get sine of x. All right? So here's the way this works. This original uv from the first parts has to stay in the problem. So there's my negative x squared cosine of x plus, so here's this plus being drug over, and then my new integral has uv. So let's say that's 2x sine x. And then minus v du gives me 2 times sine of x dx. So as you can see here, we're going down in power. We're going from x squared to 2x to 2. And that's what we needed to happen. So to finish this up, negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus c. Not so bad. In fact, if I can see in a problem that I'm going to have to do parts twice, I just usually suck it up and do parts twice. But here is this nifty little method. In your textbook, it's called the tabular method. In the movie Stand and Deliver, the professor calls it tic-tac-toe. I like tic-tac-toe. So what we're going to do with this problem, x squared sine of x, is I'm going to make 2 columns. I'm going to have a column for x squared and a column for sine of x dx. So again, here's my problem. And this is really u, and this is dv. Because from the way we set it up, I know I'm going back and forth, but see, that's my original u, and there's my original dv. Okay, so coming back over here, I want you to differentiate x squared till you get to 0. And so this is 2x, 2, and 0. And that's how I know that I've gone far enough. So now in my dv column, I'm going to integrate. So the antiderivative of sine of x is negative cosine. The antiderivative of negative cosine is negative sine. And the antiderivative of sine is cosine. So remember, our very first product is u times v. Well, here is u, and there is v right there. That's v, and this is u. So it makes sense that that product is my first term. Now, what's cool about this is I don't change that sign. That is just straight up u times v. And I'm going to put a little plus sign right here. That plus sign is just telling me do that product, don't change the sign. Now, if you remember in the formula for integration by parts, that next term is minus the integral of v du. So that's why when I do this product, I'm going to change the sign. So I get positive 2x sine of x. And then in that third, or that second v du, you really are getting a minus a negative. And so that's why this diagonal product doesn't change signs. So if you had more rows here, you would just alternate the signs of the product. So then my last term is plus 2 cosine of x. And then plus c. And hopefully, yeah, we can just look over here to the left. Yay. There's a nice little, it looks like more of a nose than a smiley face, but there you go. So that's the tabular method. So anytime you have a power greater than 1, I don't want you to shy away from the problem. X to the 6th cosine of x may be lengthy, but it's not difficult. We can come over here and do it to the side. It takes a little bit of time. We've got u and dv, basically, so I've got x to the 6th and cosine of x. And usually when you see that, they leave the dx off because it ultimately, in these products, you don't use it. So taking my derivatives till I get to 0, 6x to the 5th, 30x to the 4th, 120x to the 3rd. I hope I can do this. 360x squared. Yeah, I got this. 720x, 720, and 0. There we go. Not so bad. Now we'll do the antiderivatives, which require a little bit more thought. The derivative of sine is cosine. The derivative of negative cosine is sine. Then this is negative sine, and then you get to start repeating cosine, sine, negative cosine, and negative sine. Yay. All right, we're done. So now let's put it together. Go back to my other color, I think, because I like it better. And we're going to do these products, and I'm going to put the signage in. So that product is keep the sign, change the sign, keep the sign, change the sign, keep the sign, change the sign, keep the sign. So here we go. The first term is x to the 6th sine of x plus 6x to the 5th cosine. You're going to see your sine and cosines just switch every time. Let's see, where am I? I am at 30x to the 4th. Don't change the sign, so negative 30x to the 4th sine. And then negative 120x cubed cosine. Running out of room, I'm going to go to the next line. It looks like my next term will be positive 360x squared. Where am I? Sine. 720 is a double negative, so plus 720x cosine. And then 720 negative sine, don't change the sign, so negative 720 sine of x plus c. Again, kind of a pain, but the tabular method keeps you from having to do parts 6 times, and I consider that a win. there are some strange functions out there that need to be integration by parts, and they don't look like a product. That just looks like ln of x dx to me. You don't know the antiderivative of ln of x, and I can't develop it any other way but with parts. So again, just split it up. There's your u and your dv. U has to be a function that's differentiable, and dv has to have a dx in it. So ultimately, I'm just going to put the dx with the dv and the ln x with the u, and let's see what happens. Du is 1 over x dx, and v is x. Okay, putting that together, uv gives me x ln x, minus the integral of v du is just dx, and my answer is x ln x minus x plus c. Now, I know you wouldn't want to do that on the problem that we just did before, but ultimately, I should be able to take the derivative of my answer and get my question. So again, I would not want to take the derivative of all 7 terms up there with all of their product rules, just to see that everything cancels out, but an x to the 6th cosine with those derivatives. But this one I'd kind of like for you to see, the derivative of x ln x minus x is equal to, got to do a little product rule first, 1 d2 plus 2 d1 minus 1. And this 1 minus 1 cancels out and leaves us with ln x. So you can see that it works very nicely with this example. I told you that this last one would cause nightmares. The reason that it does is I think you can look at it and see that neither one of these functions will ever go to a constant. So believe it or not, parts works, but there's a little trick that I like to call a loop-de-loop. It doesn't matter. As long as you can differentiate and integrate both functions, it doesn't matter in this case which one is u and which one is dv. So I'm just going to do them in the order I see them, but if you wanted to switch, you would get the same answer. So u is my e to the x, and I'll let my dv be sine of x dx. So I'm just approaching this problem like I don't know any better, that it's all going to work out. Du is e to the x dx, and v is negative cosine. So that wasn't so bad. So here we go. My integral is equal to uv, so negative e to the x cosine of x, minus the integral of v du. So plus cosine of x e to the x dx. Got quiet all of a sudden. All right. And you can see from this, or at least I think you can, I give you all a lot of credit here because you're pretty darn bright, is that this is never going to go away. I mean, you could just keep doing parts forever, and you're going to go back and forth between cosine and sine. That's not bad, because notice that our original problem has a sine. So if we do parts again, we should be able to get us back to sine, and then we're just going to do algebra to finish the problem. So not so much a nightmare as we once thought. So a new u, which is basically the same u as we had before, and dv is cosine x dx, v is sine, and du is again e to the x dx. So watch what I'm going to do here. It's very important that you write your problem down, which we haven't had to do before. We've just written the uv minus the integral of v du. But I'm going to write the question down. I'm going to bring down my original uv. Now, here's the plus, and in this bracket is going to be my new uv. So e to the x sine of x minus the integral of e to the x sine x dx. And look here. Let's do a little color swap. See these? Those are like terms. If you add an integral of e to the x sine of x dx to both sides, you get two of them on the left. And that nasty problem that you thought was never going to go away is just gone away because we have looped it over to the other side and added it. So here are our UVs from doing parts twice. And then your final answer, the integral of e to the x sine of x dx, is equal to 1/2. I'm going to go ahead and factor the e to the x out. It's in both terms. I'll have a sine of x minus a cosine of x. And now that I'm finally finished, I'll tack on the plus c. So that should give you enough information to finish homework 4. I will not grade it until next Wednesday when I see you in class. Let's concentrate on preparing for the quiz tomorrow. Thanks, and I will see you tomorrow. Bye.